Welcome to Mackey's Study Circle channel. In this video, we shall see how to do the development of the lateral surfaces of the solids using the Solid Edge software. In this problem statement, we have a frustum of a pentagonal pyramid, smaller base sides of 16 mm and bigger top face sides of 32 mm and height 40 mm, resting on the HP on its smaller base, with one of its base sides parallel to the VP. We need to draw the projections of the frustum and develop the lateral surface of it. So, if we look at the problem statement, we can understand that there is no data regarding the section plane which is going to cut the pyramid, but it is very clearly told that it is the frustum of the pyramid. So, which is understood that the frustum is nothing but the remaining portion of the pyramid which is left out when a cutting plane is going to cut the pyramid in a position such a way that the cutting plane is parallel to the horizontal plane. So, that portion of the pyramid which is left out is called as the frustum. So if it is an inclined position, then it would have been called as a truncated portion. But here, the cutting plane has cut the pyramid in a plane which is parallel to the horizontal plane, and hence it becomes the frustum of the pentagonal pyramid. But the resting condition is the pentagon frustum is resting in such a way that the smaller side is on the HP and the bigger side is above the HP. So this is what is the data given to us. So now let us see how to construct the frustum first, and next let us see how to do the development of this. So now we will begin by constructing the XY line. So now instead of taking the XY line at a lower distance, we will take the XY line at a higher distance because we need to construct the frustum in such a way that it is resting on the smaller end, and then the pyramid will be inverted in the front position. So now what we can do is, first we will construct the top view of the pentagonal pyramid. So that can be done by selecting a line of thickness 0.13 mm. So let us draw a line of length 32 mm, which is the initial length, and the angle is 0. Next is 32 followed by the angle of 72, 32 followed by the angle 72 into 2, 32 followed by the angle 72 into 3, followed by 32 and then 72 into 4. So this is the pentagon. But as per the condition, one of the edges is parallel to the VP. So what we can do is go for the IntelliSketch, select the midpoint, click OK. Now go for the rotate option, select this corner and then the midpoint of the opposite edge, and then rotate it in such a way that it is exactly perpendicular or 180 degrees like this. So now let us move this to a comfortable position like this. So this is the top view of the pentagonal pyramid with one of its edges being parallel to the VP. So let us keep the midpoint off. So now let us draw the triangular faces. Again, for that, use the midpoint. So from the corner, join it to the midpoint of the opposite edges. So repeat this for all the 5 corners. So now use the trim option, and then let us trim the center lines of each triangular faces, and then complete the pyramid top view. So this is the top view. But however, this is the top portion of the frustum, and we need to construct the bottom portion of the frustum, which is having a length of 16 mm. So now before that, let us show the dimension of any one side, which is equal to 32 mm, and then let us try to take the projections. So from here, intersect the XY line. So do this from all the corner points. The angle here is 90 degrees. So now the height of the frustum is 40 mm. So from this end point, let me draw a line of length 40 mm. So we can use the extend to next, extend this portion. So this is giving us the true length. For example, if I just measure the distance between this is 32. So obviously when I go for this, you can just see that this is 16 and this distance is equal to 32. So now with this as the reference, so now let me draw a line of length 8 mm on both the sides so that I get a line of 16 mm. So this is 8 mm. So I'll simply cut the triangular face, and again here a line of length 8 mm, then drop a perpendicular, cut this slant edge. So ensure this line is having an angle of exact minus 90 degrees. So now if I just join this, the line should be equal to 16 mm. So this is what is the top face of the pentagonal prism, which is to be shown here. So this is the resting condition. That means the smaller end is on the HP. So this end will be joined like this. So now from here, let us try to construct the pyramid again. So of length 8 mm or 16 mm is the actual dimension. So 16 mm, then again 16, 16 followed by 16. So this is the view. So from here, let us draw the perpendiculars. So this is the frustum of the pentagonal pyramid. So this dimension line was just used to show the construction. So now we'll use the extend to next option. So you can just extend this, and this completes the frustum of the pentagonal pyramid. So use this extend to option, extend to next option. So extend these lines from the extreme edges of the pyramid. So this is the inverted pyramid. That means what? The plane has cut the pyramid in this direction, and this portion of the pyramid is chopped off. And then this is the frustum of the pyramid which is remaining. And the height of this pyramid will be equal to 40 mm. So this is the height of the frustum, and this is the dimension of the smaller base of the frustum and the dimension of the bigger or the top face of the frustum, that is 32 mm and 16 mm respectively, and this is 40 mm. So now we need to measure the slant edge. So you can see that none of the edges are parallel to the VP. So what we will do is we will simply draw a line, then in such a way that it is parallel to the reference line. Take the arc, cut this. So from this point, draw a line perpendicular to this XY line, and then use the extend to next option. Just extend this, and now we can extend this projection line. So trim this portion. So the actual slant edge will be from this point to the apex, or we can do it in the other way, from this point to the apex. So this is the true slant edge. So go for smart dimension. So this is the true slant edge, which is 84.5. So now we can go for the annotation. So we'll annotate the outer edges or the top face of the frustum. So this is corner A, corner B, corner C, corner D, and then corner E. Then the bottom face of the frustum on which it is resting. So we'll start from this point, that is 1, 2, 3, 4, and then 5. Similarly here, this will be A dash, and this will be B dash. This is the corner E dash. This is the corner C dash. This is corner C dash. This will be the corner D dash. So if you consider this point to be C1, then that will be C1 dash. So this is O, which is the apex, and this will be C1. That is OC1 will be parallel to the XY line. So this is XY line, and these are the reference planes VP and HP. Okay, so now we have completed the top portion of the frustum. So now let us annotate the bottom portion of the frustum. So this point, so this is 1, and next we have got 2 here, or we can call it as 1 dash, 2 dash, and 3 dash. One dash followed by 2 dash here, and then this is 3 dash, 4 dashes here, and this is the point 5 dash. So this is 5 dash. So these are the points of the lower portion of the frustum of the pentagonal pyramid. So now we need to draw the development of this. So let us just highlight this frustum, that is from A to 1, and then from 1 to 3, 3 to C dash, and then the top face of the frustum, that is from C dash to A dash, and also this portion. So this is the frustum of the pyramids. So now the slant edge is here. This is the true slant edge. So we need to draw the arc of radii 84.5 mm. So go for arc by center. Select a line of thickness 0.13. So now from any arbitrary point, let us sweep an arc of radii 84.5 So go for the line option, join one end of the arc to the center of the arc. So to avoid confusions, we'll take the arc in the opposite direction so that marking the points will become easier. So we'll draw an arc from this. So the arc radii will be equal to 84.5. Sweep an arc. So now join one end of the arc using a line. Let us now divide this arc into 5 equal parts by using the arc by center point. So from here, cut an arc of length equal to 32 mm. So consider the point of intersection. Now again sweep an arc of radii 32 mm. So repeat the steps 5 times. So basically we are dividing this into 5 equal parts. So now we can join them. Use the trim option to trim this construction arcs. So join the ends to get the base edges of the pyramid. So you can just see that everything is exactly equal to 32. So now we'll go for the annotation. So we'll consider this to be the apex of the pyramid, that is O, followed by the corners of the base edges A, B, C, D, E, and A. So now on these points, I need to mark the points 1, 2, 3, 4, 5. So you can just see that all these points 1, 2, 3, 4, 5 are on this edge itself. So what I'll do is I'll simply go for the distance between and then measure the distance between this apex and this point of intersection, 42.25. So now again I'll consider an arc from this point and then sweep an arc of radii equal to 42.25 like this, cutting all the 5 slant edges. Go for the line option. So I'll just assume that this is point 1, point of intersection is 2, then this is 3, 4, 5, and then back to 1. So use the trim option to trim this curve. So this will be the development. So go for the line option again, select a line of thickness 0.50, then join the edges of the base. So just retrace that point and then the point where it is intersecting the slant edges. So this is point 1, 2, 3, 4, 5, and this is 1 again. So now go for the smart dimension. So you can just see this. It is measuring 16 mm. So show this. This is 32, and this entire radii is equal to 84.5, and this is equal to 16 mm. So go for the annotation and enter development, indicating this is the development of the frustum of the pentagonal pyramid. So with this, we complete the construction of the problem statement. So basically, to sum up, we have got a pentagonal pyramid. So basically, it is in such a condition that it is a frustum of the pentagonal pyramid, and it is resting on the HP on one of its smaller base. And the top base is at a height of 40 mm from the small base. And this completes the front view, and this completes the top view. So the purpose of constructing the pyramid in the inverted position was just to enable us to understand that it is resting on one of its smaller bases, and hence the procedure was done in this particular inverted position. So this is nothing but the apex of the pyramid, which is O. So with this, we complete the drafting of the solution for the given problem statement. Thank you all for watching.